Okay, we are going to be talking about implicit differentiation. So implicit differentiation is when you have a graph or an equation that's not a function. So we've been dealing all this time with things that are a function where you can write it in terms of y and x, but this one would be where it's not in, like where you can't have y in terms of x. So an example would be like x squared plus y squared equals 10. This is or I guess 100. This one happens to be a circle. So as you can see, like a circle is not a function here, okay? So because of that, I don't know what dy dx is, because usually when you go from y, the derivative of y becomes dy dx, or it becomes y prime. Well, for this lesson, I'm going to start talking about dy dx, because you can have your derivative with respect to different things. Like I can have, say I had a triangle, and this is the x direction and the y direction. So say just the x direction was changing over time. So that means only this side length would be getting bigger, okay? The y would be staying the same, and I would call that dx dt. So this notation kind of makes it so that it's more expressive. So I'm going to use dy dx for this instead of y prime. So in order to do implicit differentiation, here are sort of the steps that I'm going to use. So the first thing is I'm going to take the derivative whenever I take the derivative of y, I multiply by dy over dx. So if I'm looking at my example up here, so the derivative of x squared would be 2x plus, then the derivative of y would be 2y, and then I'm going to multiply it by dy dx because of the chain rule, equals, and the derivative of 100 is 0, okay? So, and I'm going to put by the chain rule. Okay, step 2. I need to solve for dy dx. So everything with dy dx on one side, everything without on the other. Three will be to factor out dy dx and solve for dy dx. Okay, so I'm going to use this one here. So I've got 2x plus 2y dy dx is equal to 0. So I'm going to leave anything with dy dx on the left, and anything without is going to go to the right. So I'm going to subtract 2x and put it over there. So I'm going to have 2y dy dx is equal to negative 2x. Now I'm going to divide by 2y. So dy dx is equal to negative 2x over 2y, which is negative x over y. So say, for example, so this is my slope. Okay, say, for example, I was saying find the slope at x equals 6. So if I'm looking at x equals 6, then I need to figure out the y, because the slope is determined between the x and the y coordinate. And if you're looking at the, you need the y value as well, because if I'm at x equals 6, you can see that there would be 2 places there that would have 2 different kinds of slopes. So I'm going to say x equals 6 and y equals 8, okay? So if I had the x equals 6 and y equals 8, then I'm going to plug in the 6 and the 8 where as appropriate. So the slope would be negative 6 over 8, which is negative 3/4. If I wanted to write the tangent line to the equation, I could use x and y in the slope. The tangent line would be y minus 8 equals negative 3/4 x minus 6, okay? So these are sort of extra types problems that I think are on our worksheet that we should be able to do. But basically, we need to have more time with this implicit differentiation, okay? But once we do that, plugging in the numbers and doing the tangent line is no big deal, okay? So let's do another example. So let's do 3x squared plus x squared y equals 8, okay? So I'm going to take the derivative. So the derivative of 3x squared is going to be 6x plus, what rule do I need to use here? Well, I need to use product rule. So I've got the derivative of x squared is 2x, and I'm going to leave the y alone. It doesn't get dy dx because I didn't take the derivative of y. Plus, then I'm going to leave the x squared alone, and the derivative of y would be 1, and it's going to be 1 dy dx equals the derivative of 8 is 0. So now that I'm here, I'm going to put everything with dy dx on the left, everything without on the other side. So I've got x squared dy over dx is equal to negative 6x minus 2xy. Now I'm going to divide by x squared, so I get dy over dx is equal to negative 6x minus 2xy over x squared. Okay, let me turn the page and let's do another one. Okay. All right, let's do 4y squared plus xy cubed equals 10. All right, so the derivative of 4y squared would be 8y. Because I took the derivative of y, he needs a dy dx. Plus, I'm going to have to use product rule here. So I'm looking at the x. The derivative of x is 1. Then I'm going to leave the y cubed alone. He doesn't get a y dy dx because I did not take the derivative of him. Plus, then I'm going to leave the x alone, and the derivative of y cubed is 3y squared dy dx equals, and that's 0. Okay. Anything without dy dx is going on the right. Anything with dy dx is going to go on the left. So I'm going to have 8y dy dx plus 3xy. Notice I just moved the x inside there. Squared dy dx is equal to negative y cubed. So now I'm going to factor out the dy dx. So dy dx is going to be 8y plus 3xy squared equals negative y cubed. So therefore, dy over dx is equal to negative y cubed over 8y plus 3xy squared. Okay, let me do another one. Number 3. 4 sine y plus 2y squared is equal to 7x cubed, something like that. Okay, so I'm going to take the derivative. The derivative of 4 sine y would be 4 cosine y dy dx plus, this would be 4y dy dx is equal to 21x squared. So anything with dy dx is already on the left. Anything without is already on the left. So now I'm going to factor out a dy dx. 4 cosine y plus 4y equals 21x squared. So now I'm going to solve for dy dx. dy dx is equal to 21x squared over 4 cosine y plus 4y. Okay. Let me do one more, and then I'm going to talk about second derivative. Okay. So for x squared y cubed plus 3xy squared equals 10. I don't know why I always like to have it equal a number. Honestly, I think this is just how they kind of do it. So I need to do product rule here and product rule here. So what's the derivative of x squared? 2x. Y cubed is going to stay the same, plus x squared stays the same, and that would be 3y squared dy dx. All right, next one, 3x is part of the product rule. The derivative of that is 3. So 3, and then I'm going to leave the y squared alone, plus 3x, and the derivative of y squared is 2y dy dx equals, and the derivative of 10 is 0. So these two terms here need to be moved to the right-hand side. 3x squared y dy dx plus, and this is going to be 6xy dy dx equals negative 2xy cubed minus 3y squared. This is when math looks really fun, doesn't it? So I'm going to factor out the dy dx. Basically, I'm just dividing by these terms on the bottom. So it's going to be negative 2xy cubed minus 3y squared all over 3x squared y plus 6xy. I can't cancel anything out of it. It's just going to stay and look ugly. Again, if they gave you an x and y value, you could actually plug in the x and y and figure out the number, and then you could do an equation for a tangent line if you wanted to. Okay, so now I'm going to talk about the second derivative. The second derivative tends to get long. Okay, so let me turn the page. So this is going to be implicit second derivative. So I've got x squared y is equal to, let's do x squared y squared is equal to 5. Okay, so I am going to have to use, actually, I don't think I want to do that one. Let's do x squared plus y squared equals 5. Okay, so I'm going to use implicit here. So the derivative of x squared is 2x plus 2y dy dx is equal to 0. So I'm going to move everything over to the other side. So I'm going to subtract this. So I've got 2y dy dx is equal to negative 2x. When I divide by 2y, I'm going to get dy over dx is equal to negative x over y. Okay, so now I'm ready to take the second derivative. So I want to find dy, d squared y, dx squared. So I'm going to have to use quotient rule, okay? So I'm going to go the ho's y, the d high is negative 1. Ho d high less high is negative x, and the d ho is going to be dy over dx. Draw the line, square the ho. So I'm going to simplify this. This is going to be negative y plus x dy over dx over y squared. Okay, so that's not so bad, except do I already know what dy dx is? I do. It's right up here above. So I can plug the negative x over y here for dy dx in its place. So I'm going to get negative y plus x times, instead of dy dx, I'm going to get negative x over y all over y squared. Okay? So I need to kind of simplify it. Like whenever I'm doing the second derivative, I always need to plug in the dy dx wherever it is. So if I'm doing this one, this doesn't look very simplified. It's not wrong, but it doesn't look very simplified. The problem with it is this stupid y on the bottom. So how would I get rid of dividing by y? Would be to multiply by y. So if I multiply the top by y and the bottom by y, I'm not changing the problem at all. Does that make sense? So then I'm going to distribute the y times negative y would be negative y squared. The y times the y here is going to cancel. So see, I've got x times negative x. So that's going to be negative x squared over y squared times y should be y cubed. And that is my derivative, my second derivative. Okay. All right. So I think I've explained enough for the work that we're going to do. I'm also going to be Zooming during class. So if you want to come and do some extra practice and watch me go over them, I suggest that you Zoom during class at this time, because for the first part of class, I'm just going to be practicing going over it. Okay, thank you.